Welcome to the deep dive. Today, we're really digging into something that's, well, it's changing everything, isn't it? Unlocking AI potential in big organizations.
Yeah, enterprise AI, it's huge. And we've been looking at this guide that tackles it head on. It's interesting because it targets both sides of the house.
Exactly. The tech teams, the developers doing the building.
And the management side, the people setting the strategy and needing the results.
That's the core challenge, right? That
Right.
divide. AI isn't just another piece of software.
No, not at all. It's properly transformative.
Yeah.
But you need that deep technical know-how and the strategic business vision. And, well, a lot of companies stumble because those two worlds just don't connect properly.
So this guide and what we're doing here today is trying to bridge that gap, give people a practical map.
Pretty much. Think of this as maybe a shortcut through the complexities. We're pulling out the key insights from the guide.
Helping you figure out how the technical side and the strategic side have to work together to get those real AI benefits. Basically, get you up to speed without reading the whole thing cover to cover.
Right. We'll cover the whole journey the guide lays out, starting with, just understanding the AI landscape itself.
Then looking at whether your organization is actually ready for it. That's a big one.
Huge. Then how developers and management can actually work together effectively.
Choosing the right tools. That market is crowded.
Oh, yeah. And facing the challenges, because there will be challenges.
Definitely. Plus, the ethics can't ignore that.
Absolutely not. And then, how do you even know if it's working? Measuring success.
And finally, a look ahead. What's next?
It's a packed agenda, but it all ties together.
Okay, let's dive in. Unlocking enterprise AI potential. Where does the guide start us off?
Wisely, it starts with the basics. Understanding the terrain, the AI landscape.
And the point is, this landscape isn't fixed, right? It's massive and changing.
Yeah. Incredibly fast. And the guide makes the point that trying to jump into AI without knowing what is like, I don't know, setting sail without a map or knowing about different types of boats.
So staying informed isn't just nice to have, it's fundamental. The source mentions specific branches of AI that are really hitting home in businesses now.
It does. It focuses on three big ones: machine learning, NLP, natural language processing, and robotics.
Not the only types, obviously, but where a lot of the current enterprise value is coming from.
Exactly. They're the heavy hitters right now.
Okay, so let's unpack those. Machine learning, ML. We hear it constantly. What's the guide's angle on it?
At its core, it's about systems learning from data, finding patterns, making decisions or predictions. Crucially, without being explicitly programmed for every single scenario.
You feed it data, it learns, it generalizes.
That's the idea. But
Yeah.
in business,
Mhm.
the guide points to how this drives efficiency, innovation, competitive advantage, all the good stuff.
Like predictive analytics.
Perfect example: forecasting sales much more accurately than old methods, or predicting machine failure before it happens.
Predictive maintenance, yeah. That saves serious money.
Huge savings. Or figuring out which customers might be about to leave so you can try and keep them. That's ML, learning those patterns from customer data. And it's behind a lot of automation, too, the kind that needs to adapt to complex situations.
That predictive maintenance example really clicks. You've got an ML model analyzing sensor data vibration, temperature,
Usage logs, maybe?
and it predicts the best time to do maintenance, not too early, not too late.
Exactly. A direct link from a technical ML model to a clear business outcome. Less downtime, lower costs.
Okay, that makes sense. Next up, natural language processing, NLP.
Right. This is all about computers understanding and working with human language. Text, speech.
And the applications in business are just booming, aren't they?
Absolutely. Think smarter chatbots. Not just following a simple script, but actually understanding the nuance, the sentiment in what a customer is asking.
So they can provide better support, maybe even resolve the issue without needing a human.
That's the goal for many queries. It's also massive for analyzing unstructured text data.
What kind of data?
Oh, tons of it. Customer reviews, social media chatter, emails, internal reports. NLP can pull out key themes, understand sentiment, spot compliance risks, automatically categorize things.
There's just so much text in any business. Trying to read it all manually is impossible.
Impossible. NLP unlocks the value trapped in that text. Analyzing feedback isn't just counting words. It's understanding the feeling behind them. That feeds directly into product development, customer service improvements.
Okay, and the third area, robotics.
Yeah, and the guide implies, rightly, that in the enterprise world, this isn't just physical robots on a factory line, though that's definitely part of it.
It's also software robots, RPA.
Exactly. Robotic process automation. Using software to mimic how humans interact with digital systems, clicking, typing, moving data between applications to automate those repetitive rules-based computer tasks.
So automating things like data entry from an invoice into the finance system.
Yep. Or transferring customer info between the CRM and another platform,
Huh.
processing standard requests in a service center, generating routine reports, that kind of thing.
And RPA often gets blended with AI, right?
Often, yes. You might add computer vision so the software bot can read a screen, or NLP so it can understand instructions in an email, making the automation smarter and more flexible.
So physical robots for physical tasks, RPA for digital tasks, both aiming for efficiency.
And freeing up people for more complex, valuable work. But the deeper point the guide pushes towards isn't just listing these.
It's how they fit together.
Right. And why a business would choose one or maybe combine them. You could use ML to flag urgent documents, NLP to pull out key info, and RPA to then push that info into 3 other systems automatically.
Creating connected AI workflows.
That's it. And the guide stresses that understanding these tools, ML, NLP, robotics, isn't just for the techies.
No, for anyone in the business, right? Because these are the potential solutions to your problems or the keys to your opportunities.
Exactly. You need to know what's possible with these tools to even spot where AI could help or what strategic questions you should be asking. You wouldn't build a strategy around, I don't know, hammers if you didn't know what a hammer did.
Makes sense. Know your tools. Okay, so that's the landscape. But just knowing what's out there isn't enough. The guide quickly pivots to readiness. Are you actually ready to use these tools?
And this chapter is, let's say, non-negotiable, according to the source. It flat out says, before deploying AI tools, enterprises need to assess their readiness.
And skipping this step is where things go wrong.
So often. You can have a brilliant idea for AI, but if the ground isn't prepared internally, you're heading for failure.
Okay, so what are the critical readiness factors the guide points out?
Number one, and it's usually the biggest headache, data maturity.
Data maturity, what does that really mean in practice?
It's kind of a holistic look at your data situation. Is the data you need even available? Is the quality any good, accurate, complete, consistent? Can the teams who need it actually get to it, or is it locked away in silos? And is there proper governance rules around how it's collected, stored, used, kept secure?
It's the raw material if your data is messy, incomplete.
Garbage in, garbage out. It's a cliche, but profoundly true for AI. AI learns from the data. Feed it junk, you get junk AI.
So the guide emphasizes good data is essential.
Absolutely. If your customer records are a mess, duplicates, conflicting info, or your machine sensor data has gaps or weird formats, any AI trying to use that is going to struggle, or worse, give you dangerously wrong answers.
Can you give a concrete example of low data maturity being a roadblock?
Sure. Imagine trying to build a single customer view for personalization, but your sales data is in one system, service history in another, website clicks in a third. And they don't link up easily, use different customer IDs, have inconsistent timestamps. That's low maturity, creating a massive barrier right there. Very clear. Okay, data maturity is hurdle 1. What's next?
Infrastructure. The plumbing, the horsepower needed.
What kind of infrastructure are we talking about?
Well, AI, especially training the big models, needs serious computational power and needs to handle lots of data. So you need enough processing power, and often that means specialized hardware like GPUs.
Graphics processing units. Why those specifically?
Because training many AI models, especially deep learning, involves doing tons of calculations simultaneously, in parallel. GPUs were designed for graphics, which needs exactly that kind of parallel processing for pixels. So they're way faster than regular CPUs for these AI tasks.
So without enough GPUs, training takes forever.
Weeks, maybe months, instead of hours or days. It makes iterating and improving models incredibly slow, almost impractical sometimes. You also need scalable storage for potentially huge data sets and robust cloud platforms or powerful internal data centers to run it all.
Got it. Compute, muscle, and storage. What's the third critical factor?
This one's maybe less tangible, but just as vital. Organizational culture.
The people side. The people side. The mindset. Does your organization's culture actually support AI adoption? Are people willing to experiment? Do they make decisions based on data? Are they comfortable with change? Because AI will bring change.
And if the culture is resistant, if people are scared or skeptical.
It can kill an AI project stone dead. If employees think AI is just coming for their jobs, if leaders trust their gut over data insights, if departments hoard their data and refuse to change old processes, you'll hit wall after wall.
So you need buy-in.
You need buy-in, trust, and a willingness to see AI as a tool to help people, not just replace them. The guide implies fostering that kind of culture is key.
The source mentions evaluating existing resources based on these three things: data, infrastructure, culture. How do you actually do that evaluation?
It needs a proper process. For data, maybe a full data audit, map your sources, check quality, see who owns what, find the access bottlenecks.
Okay.
For infrastructure, it's taking stock. What hardware, network, cloud capacity do you have now? What will the AI likely need? Do a gap analysis.
And for culture, that sounds harder to measure.
It is. It might involve surveys, workshops, interviews across the company, trying to gauge the understanding of AI, the attitudes, find the potential champions, and the pockets of resistance.
And the whole point of this assessment, the guide says, is to build a tailored roadmap for AI adoption, specific to your organization.
Exactly, not a generic plan. If your assessment shows data quality is terrible, step one on your roadmap must be fixing the data before you try fancy ML. If infrastructure is weak, the roadmap prioritizes cloud migration or hardware upgrades. If culture is the problem, you need change management, communication, maybe starting with small, less threatening pilot projects to build confidence.
Address your specific weaknesses first.
Address the bottlenecks identified in the assessment. Otherwise, you're building on shaky foundations.
So this readiness phase is all about looking inward first, doing the foundational work.
It's essential prep work. Skipping it is just asking for trouble down the line.
Okay, this focus on culture and readiness leads perfectly into the next big theme from the guide: the human element. Specifically, that crucial link or often disconnect between the tech teams and the business leadership.
Ah, yes. Bridging the developer management divide. This is where so many AI initiatives stumble, even with good tech and decent data. The guide is very clear. Collaboration is essential.
Why is that gap so common, though?
Fundamentally, it's different priorities, different languages, different worlds almost. Developers are deep in the weeds, algorithms, model accuracy, data pipelines, coding standards. They talk hyperparameters, APIs.
While management is focused on the bottom line revenue, costs, customer sat, market share, risk, they talk ROI, KPIs, strategy.
Both totally valid, totally necessary perspectives, but they don't always translate easily. A developer might celebrate getting a model from 98% to 98.5% accuracy, a real technical feat. Management might just see time spent for negligible business impact if 98% was already good enough.
So the guide suggests ways to facilitate better communication, not just more.
Right. Things like regular cross-functional meetings where both sides are actually present and talking to each other. And crucially, finding a common language.
Translating tech talk into business impact and business needs into technical requirements.
Exactly. Devs need to explain why a technical choice matters for the business. Managers need to explain what business outcome they need the tech to achieve.
Which ties directly into aligning objectives. How do you make sure the developer optimizing a model is actually helping the business goal, like reducing customer churn?
By defining clear shared goals right from the start. Management says we need to reduce churn by 15%. Developers then propose how AI can help and define technical metrics like model prediction accuracy for likely churners that directly serve that business goal. Success isn't just the accuracy, it's hitting that 15% reduction.
That creates a shared vision then. Everyone knows why they're doing this.
That's the idea. When everyone understands the bigger picture, the strategic purpose of the AI work, it's much more motivating and collaborative. Developers see how their code impacts the customer. Managers see how tech choices impact timelines or costs.
The guide also implies digging into roles and responsibilities helps here, defining who does what.
Oh, absolutely. Lack of clarity there leads to chaos.
Yeah.
Things get dropped, fingers get pointed. Management usually owns the what and why, strategy, budget, value. Tech owns the how, design, build, deploy.
But there must be overlaps, shared areas.
Definitely. Defining the use case, checking feasibility, ongoing monitoring that needs both sides. And data governance is a huge one. Who ensures the data stays good over time? The tech team managing the pipeline or the business unit owning the source system? Defining those handoffs and shared ownerships avoids major problems.
And fostering that culture of innovation again, valuing input from both tech and business.
It's critical because the best ideas often come from that intersection. Tech knows what's possible. Business knows what's needed. You need forums where those two perspectives can meet and spark ideas, workshops, joint teams, whatever works. Ignoring one side means you either build tech nobody needs or you miss opportunities because you didn't know the tech existed.
So it really hammers home that AI success is as much about people, communication, and organization as it is about the tech itself.
It's about building the right organizational muscle for AI. You can't
Yeah.
just bolt it on.
Right. Okay, so you've got the organizational muscle warming up, you have a shared vision.
Right.
Now you actually need the tools. And the guide acknowledges choosing them is tough. Daunting, it says.
Understatement. The market is flooded. Cloud giants, specialized startups, open source libraries. It's overwhelming. And picking the wrong tool isn't just inconvenient. It can be a very expensive mistake.
So how do you navigate that? What criteria does the source suggest?
The number one filter, always, is alignment with your business goals. Does this tool actually help solve the specific problem you defined earlier?
Sounds simple, but probably gets overlooked.
Easily. People get excited by shiny new tech. But if your goal is, say, better email support, you need a solid NLP tool for classification and maybe generation. You don't necessarily need the world's best image recognition platform, even if it's popular. Tool fit for the job.
Okay, align with the business goal. What's the second criterion?
Alignment with your technical requirements. This is about fitting into your existing world. Does it play nice with your current data setup? Databases, data lake, cloud?
Does your team have the skills to use it?
Crucial point. Or is the learning curve massive? Can it handle your data volume and type? Does it meet your company's specific security and compliance roles? Picking a cool tool that needs a whole new tech stack your team doesn't know, or that fails your security audit, that's just creating more problems.
The source mentions platforms and features. How should we think about the different types of tools out there based on its guidance?
But you can broadly categorize them. You've got the big cloud AI platforms, AWS SageMaker, Azure ML, Google AI platform offering a wide range of services. Right. Then you have powerful open source frameworks like TensorFlow, PyTorch, Scikit-learn, huge flexibility and control, but need deep expertise.
Depth and customization.
Exactly. And then there are more specialized tools or APIs, maybe pre-built solutions for things like sentiment analysis, facial recognition, anomaly detection, often sold as a service. The guide's criteria help you figure out which category and then which specific tool within that category makes the most sense for your situation.
When you're evaluating specific tools, what kind of features, beyond just the core AI stuff, does the guide imply are important for enterprise use?
It points towards things that make it work in an enterprise context. Ease of use is big who's using it. Hardcore data scientists, maybe data analysts, or are there low-code options for business users?
Pre-built models.
Yeah, accelerators. Things like pre-trained models for common tasks and save a lot of time. Deployment options are key to cloud, on-prem, mobile edge devices. How easy is it to get the model out there and integrated via APIs?
And security, obviously.
Non-negotiable in enterprise. Robust security, access controls, audit logs, compliance certifications, all vital.
The guide really digs into 3 evaluation criteria: scalability, flexibility, and user adoption. Let's start with scalability. Why is that so critical for enterprise?
Because enterprise AI rarely stays small. Your pilot project might work fine, but what happens when you want to roll it out globally or handle 100x the data volume? Scalability means the tool and its underlying infrastructure can grow with your needs without performance tanking or costs exploding. It has to handle enterprise scale.
Makes sense. And flexibility.
Business needs change. Data sources evolve. You want to tackle related problems. Flexibility means the tool isn't a one-trick pony. Can it adapt? Can it connect easily with other systems you use? A tool that works in a silo is much less valuable than one that integrates smoothly into your wider tech ecosystem.
And user adoption even for technical tools. Why does that matter so much?
Because tools don't use themselves. Who are the users? Data scientists need good development tools. Data engineers need easy ways to connect data. Ops teams need simple deployment and monitoring. If a tool is clunky, poorly documented, or needs super rare skills, people just won't use it effectively. Development slows down, value isn't realized. A technically brilliant tool nobody uses is worthless.
So choosing tools isn't just a tech decision, it's strategic. It needs that business alignment, technical fit, and practical usability.
It's about placing smart bets on the technology that will actually help you achieve your goals.
Right. But even with the best tools, the best plans, the guide is refreshingly honest. Implementing AI is not without its challenges. Things will go wrong.
And knowing that upfront helps you plan for it, manage expectations. The guide lays out some common pitfalls.
We talked about data quality in the readiness phase, but how does it bite you during implementation?
Well, you might know your data isn't perfect, but the pitfall is when you actually try to train a model on it. incomplete data, errors, inconsistencies, hidden biases, they all directly poison the model.
So the model performs poorly or unfairly.
Exactly. Try building a fraud detection model with messy transaction data missing fields, inconsistent codes, typos. Your model will likely miss real fraud or, just as bad, flag perfectly normal transactions. That's the data quality problem hitting the real world.
Okay, so bad data leads to bad AI outcomes. What's another common challenge the source highlights?
Lack of skilled personnel. This is a persistent one.
Finding people who know how to do this stuff?
Finding and keeping them. You need data scientists for the algorithms, data engineers for the pipelines, ML engineers to get models into production reliably and keep them running. These are specialized, high-demand skills.
And if you don't have them,
Projects stall. Models get built poorly. Maybe they don't scale. You can't maintain the systems properly. It becomes a major bottleneck.
how does the guide suggest tackling that challenge?
It implies a need for a deliberate talent strategy. That means investing in training your existing people, upskilling engineers, analysts. It means competing hard to hire experienced AI talent. And often it means strategically using external partners, consultants, vendors to fill gaps or help build your own team's capability over time. It's not just one solution.
Makes sense. And the third pitfall mentioned, integration hurdles.
Ah, yes. AI systems rarely live in isolation in a business. They need to connect to everything else.
Pull data from old databases, push insights into the CRM, talk to the manufacturing system.
Exactly. And enterprise IT is often complex. A patchwork of systems built over years, different technologies, data locked in departmental silos. Getting an AI model trained might be one thing, but weaving it seamlessly into those existing workflows and systems can be incredibly difficult.
The guide mentions learning from real-world examples, successes, and failures. We don't have specific cases here, but can we illustrate these pitfalls?
Sure. Imagine a retail company trying AI for personalized offers. They fail because their customer data is spread across incompatible sales, marketing, and loyalty systems. Classic integration and data silo problem.
Okay.
Or a bank wants to use AI for loan decisions but can't find enough data scientists familiar with fairness metrics and explainable AI techniques. That's a skills gap leading to potential ethical or performance issues.
And a success.
Maybe a logistics firm successfully implements predictive maintenance for its fleet. They invested upfront in standardizing sensor data collection, data maturity, use a scalable cloud platform infrastructure, and train their mechanics alongside data analysts, skills and culture.
Thinking through those scenarios makes the challenges feel very real.
And the point is, knowing these are common issues helps you anticipate them. You can allocate budget for data cleaning, plan for training or hiring, factor in time for integration work. Forewarned is forearmed.
Definitely valuable. Okay, moving on from the practical challenges to something equally critical. Ethics. As AI gets more powerful, the guide stresses that ethical standards are essential.
Paramount is the word the source uses. And it's because AI isn't just optimizing spreadsheets anymore. It's influencing decisions about people's lives and livelihoods.
Hiring, loans, healthcare.
Exactly. Insurance, parole decisions. The potential impact is enormous. And without strong ethical frameworks, AI can easily cause real harm.
One of the biggest concerns is bias in AI models. How does that happen?
Mostly, it comes from the data used to train the model. If your historical data reflects societal biases like past hiring practices that favored certain groups or lending patterns that discriminated the AI, learns those biases.
It just replicates the past, potentially at scale.
It automates and amplifies past inequities. Bias can also creep in through how developers choose features for the model or even the algorithm design itself, sometimes unintentionally.
And the consequences for a business deploying a biased model are significant.
Huge. Legally, financially, reputationally. Think discriminatory hiring tools, unfair loan application rejections based on proxies for race or gender, skewed marketing campaigns. Beyond the obvious moral issues, it's terrible for business trust and can lead to massive fines or lawsuits.
Another major ethical area is privacy. AI loves data, often personal data.
It does. And that raises big questions. How are you collecting that data? Is it secure? Who sees it? Are people aware of how it's being used? This is where regulations like GDPR in Europe or CCPA in California are so important.
Enterprises have to navigate that complex legal landscape.
They absolutely must. Consent, anonymization where possible, robust security to prevent breaches. AI's hunger for data makes responsible data stewardship even more critical.
The guide also emphasizes transparency or explainable AI XAI. Why is it so important to know how an AI reached a decision?
Several reasons. Trust is a big one. If an AI affects you, denies you something, flags you for something, you need to understand why.
Accountability.
Yes. Also, finding and fixing bias. If you can see what factors the AI relied on, you can check if they're appropriate or discriminatory. It's also vital for debugging if the model makes a mistake. Explainability helps figure out why. And regulators are increasingly demanding it, especially for high-stakes applications.
So how do companies actually do ethical AI? The guide suggests it's more than just talking points.
It has to be embedded in the whole process, developing internal ethical guidelines, maybe setting up review boards with diverse members to vet projects for ethical risks before they start.
Training the tech teams on bias detection and mitigation.
Definitely. Using tools specifically designed to test for fairness. Having clear processes for auditing AI decisions and allowing people to challenge or appeal automated outcomes. It's an ongoing commitment.
So this isn't just a nice to have, it's fundamental for trust, compliance, risk management.
And ultimately, for ensuring AI is actually beneficial. It's a core responsibility for any organization using this tech. Proactive effort here is far, far better than cleaning up an ethical disaster later.
Absolutely. Okay, so we've covered a lot: landscape, readiness, collaboration, tools, challenges, ethics. Now, the bottom line question: how do you know if any of this is actually working? Measuring success and ROI.
Crucial, and often surprisingly tricky. The source says measuring success is crucial, but it acknowledges the difficulty.
Why is this so hard sometimes?
Well, like we said, AI often plugs into complex existing processes. Isolating its specific impact can be tough. Did sales go up because of the AI recommendation engine or because of a marketing campaign or seasonality or something else?
Right. And some benefits are harder to put a dollar value on, maybe, like better decisions.
Exactly. Improved decision quality, better innovation, those are real benefits, but they don't always show up neatly on a P&L statement in the first quarter.
The guide talks about KPIs and metrics, noting that developers and managers often track different things.
They do, naturally. Developers focus on the technical health of the AI system itself.
Like model accuracy, how often it gets the prediction right.
Right. Accuracy, precision, recall how well it finds what it's looking for without too many false alarms. Also, speed. How fast does it give an answer? Uptime, reliability. Is the tech working as engineered?
And management focuses on the business outcome metrics.
Precisely. Did productivity go up because tasks got automated? Did revenue increase from those AI-driven recommendations? Did costs go down due to predictive maintenance? Did customer satisfaction scores improve after deploying the chatbot? Is it actually moving the needle on business goals?
So the real challenge, and what the guide implies we need methods for, is connecting those two sets of metrics, showing how technical performance leads to business value.
That's the key. You need rigorous ways to track the impact. Maybe A/B testing, run the process with AI for one group, without it for a similar control group, and compare results.
So you can isolate the AI's effect.
Or detailed cost-benefit analysis, how much did the AI system cost versus how much did it save in prevented downtime or reduce manual effort. Using analytics to directly attribute changes in business KPIs, like conversion rates, to the AI intervention.
It requires setting up that measurement framework beforehand.
Absolutely. You need to define success collaboratively, what technical and business metrics matter, and then build the systems to track them. How does that 5% better model accuracy in fraud detection actually translate to dollars saved from fraud? You need to connect those dots and measure both.
This seems essential for justifying the investment, getting continued support, and knowing what to scale up.
And for learning. Measurement tells you if it's working, and if not, helps you figure out why so you can fix it or pivot. It's not just reporting, it's feedback for improvement.
Okay, makes perfect sense. Finally, the guide takes a look ahead. AI isn't standing still. What does the future hold for enterprise AI?
Yeah, this is important because, as the source implies, AI adoption is a journey, not a destination. You need to keep an eye on the horizon.
What kind of innovations does the guide hint at?
Things like more sophisticated, potentially more general-purpose models, like the big foundation models we're seeing now, capable of tackling more tasks with less specific training.
Less specialized models.
Potentially. Also, things like explainable AI becoming more mainstream, maybe even required. And AI systems gaining more autonomy, making more complex decisions, or taking actions with less direct human oversight. Within safe boundaries, of course.
And where might these emerging applications pop up in businesses?
Beyond what we see today, maybe true hyper-personalization, tailoring entire customer experiences, not just ads. More sophisticated decision support for complex strategic choices, market entry, supply chain design. Maybe even AI assisting in creative tasks. drafting content, initial design concepts, analyzing trends to suggest new strategies.
The guide also prompts a deeper look at AI integrating with other technologies like IoT and blockchain. Let's start with IoT, the Internet of Things. How does that combo work?
IoT puts sensors everywhere, on machines, in buildings, on products, generating floods of real-time data about the physical world. AI thrives on data. Put them together and you can do amazing things.
Like supercharged predictive maintenance.
Exactly. Analyzing subtle vibration patterns from thousands of sensors to predict a failure minutes away, not days. Or optimizing energy use in a smart building by analyzing sensor data on occupancy, temperature, light levels in real time. It's about getting intelligent insights from the physical environment at scale.
Okay. And the intersection with blockchain. That seems less obvious.
It's more about trust, security, and auditability. Blockchain provides a secure, transparent, unchangeable record. So you could potentially use it to securely share data for AI training between different companies, say, in a supply chain, without exposing sensitive raw data, perhaps using techniques like federated learning.
Maintaining privacy while still allowing collaborative AI.
That's one idea. Another is using blockchain to create a tamper-proof log of decisions made by an autonomous AI system. So you have a verifiable record of why the AI did what it did, which helps with transparency and accountability.
All this integration, more complex AI, IoT, data streams, maybe blockchain sounds like it has big implications for IT infrastructure, as the source suggests.
Huge implications. You need much more robust data pipelines to handle IoT data volumes. You need compute power distributed differently, maybe more edge computing, to process data near the sensors.
Not just central cloud processing.
Right. AI models will need to be deployed everywhere, cloud, edge, data center. And demands for security, data governance, and verifying AI actions will only increase. IT architecture has to become more agile, more distributed, inherently more intelligent itself.
So looking ahead helps companies plan strategically for these shifts in technology and infrastructure.
You have to anticipate where things are going to stay ahead or even just keep up. It reinforces that this is a continuous evolution.
Okay, so let's just take a breath and summarize the key takeaways from this deep dive, drawing on the guide's wisdom.
Well, we started by mapping the AI landscape, understanding ML, NLP, robotics as key tools for business.
Then stress that crucial inward look, assessing your readiness in data, infrastructure, and importantly, culture.
We really dug into bridging that gap between tech teams and business leadership. Collaboration, communication, shared goals, absolutely vital.
And navigating the complex choices around AI tools, making sure they align with business needs, tech realities, and are actually usable.
We face the common challenges head on: data quality, skill gaps, integration pain. Knowing them helps you prepare.
Highlighted the non-negotiable importance of ethics, tackling bias, ensuring privacy, striving for transparency.
Covered how to actually measure success, connecting technical performance to real business outcomes and ROI.
And finally, looked ahead at how AI continues to evolve and integrate with other tech like IoT and blockchain, changing the game again.
And the core message running through it all: unlocking AI's potential isn't just about tech. It's strategic, it's organizational. It needs everyone involved, developers and management, working together.
It's a whole business transformation, really. It requires constant learning, adapting.
Collaboration is key.
Which leaves us with a final thought for you, our listener, to mull over after this deep dive. Thinking about how fast AI is moving, getting smarter, weaving itself into everything with IoT and other tech, creating this incredibly interconnected, intelligent enterprise. How truly prepared is your organization?
And maybe more personally, how prepared are you? Not just to get AI projects running today, but to navigate the ongoing technical, ethical, and strategic complexities of this AI-driven world that's unfolding right now.
As those lines keep blurring between tech and business, what's your role in making sure this powerful transformation is effective, yes, but also responsible and genuinely beneficial for everyone?
Something to think about.
We hope this discussion has given you a solid framework and maybe some concrete ideas for tackling AI in your own world.
Thanks for joining us on the deep dive. Keep exploring, keep questioning,